Hello, so this is going to be the first of a new little mini-series, or well, maybe quite a long series actually, on blockchain and Bitcoin. Both of these concepts are sort of very hot at the moment. I think these days a lot more talk is about blockchain and the things that it can do beyond Bitcoin, and it's extremely exciting. Some radical people out there really think it's going to change the world. In any case, it's a very interesting thing to discuss, both in terms of technology, in terms of the way it works mathematically, although this is not going to be mathematical. But it will teach you exactly how it works from a very, very deep level, as long as you follow from the beginning, okay? So if you've seen my previous series on SSL certificates, so you might be familiar with my sort of screencast style. Disclaimer, I'm not an artist, and my handwriting is pretty bad, and I'm just getting to know the graphics tablet. So please bear with me, but I'll try and keep it clear. I wanted to sort of keep it in a sort of classroom style, and what I mean by that is that from the second video onwards, I'm going to actually involve my girlfriend, and she's going to take part in the sessions. She doesn't know any of this stuff, and I'm going to teach her. She's going to ask questions and keep me right if I stray or say something that doesn't make sense. So, and she's already seen this first video 3 times, which we shot over and over again, and the mic wasn't working, so she basically refuses to watch it again. But from the second one onwards, she'll be in there, and I think that's quite a good way to sort of to style the dynamic. Okay, so then I'm just going to, so the structure of the course, basically, I'm going to start today with a very simple analogy to kind of explain what blockchain really is. And it's not going to be technical, it's not going to be mathematical, and it's not even going to involve a computer at all. It's going to be kind of a story, which is a bit of an analogy, a bit of a silly analogy, but hopefully it'll illustrate the kinds of things that blockchain is trying to do. And then, from then, I'm going to basically recap the sort of the key concepts around cryptography that we'll need to know as we sort of dive into Bitcoin. So it's going to be things like hashing. I do have a previous video on hashing and also public key, private key cryptography, and I also have videos on them from my previous SSL stuff. So I will link those down below, but I'll also do a quick summary just in case you don't want to get bogged down in SSL stuff. Then I'm going to, as I said, we're going to sort of do a deep dive into Bitcoin, and I'll put a link here so you can skip this intro if you just want to see the analogy. But so Bitcoin is a very, very interesting topic in itself, both in terms of economics and etc. But it's also a really, really good way to actually illustrate how a real blockchain works. So when that's done, that's going to be quite a few sessions, because the aim is to basically teach you in great deal of depth about Bitcoin. When that's over, I'm going to basically step out of Bitcoin and go into blockchain concepts beyond Bitcoin and even beyond digital currencies. So things like Ethereum, smart contracts, all that kind of stuff that really some people say is the kind of the more exciting future possibilities for blockchain. So anyway, so let's get started, because there's quite a lot to get through, and I'm going to try and keep these as short as I can, but apologies in advance, they're not going to be super short, because I do want people to be able to follow in depth. So I might repeat myself once in a while. That's just the way it is, okay? So basically, what I want to do is I'm going to tell a little story that hopefully illustrates what exactly this whole blockchain thing is all about, okay? So essentially, what I'm going to say is, imagine there's a guy, right, and you're about to see how bad my drawing is, right? There's a guy who works in a bank, okay? He works in a bank, and he works in the kind of back office, and his job is to take all of the checks that get paid over the counter in the bank, right? Each week, okay? Let's say each week there are something like 1,000 checks coming into this particular branch, right? So 1,000 checks come in, and his job is nothing more than to sit in that office and store these checks in a place where it's secure, and also that it is impossible for anybody to go and modify, like, let's say, take one of these checks that's been stored away, modify something that's written on there, add one in, or remove one. So basically, you can't update, insert, or delete any of the record of those checks. So what the bank needs to do is to basically keep a chronological record of every single check that has ever come in through the doors, right? So this guy sits there and says, okay, what do I do here? And he thinks, okay, what I can do is this, right? Now, there's a couple of things you need to sort of suspend disbelief in the sense that he's going to use a piece of equipment which is not really feasible, but the analogy kind of holds, I think, at least. So he takes first of all, so this is week one, right? He decides, right, I've got a new scheme. This is week one of the new scheme. And so his job is to basically take all the checks from Monday to Friday and store them away. So week one, he's going to basically get an empty cardboard box, okay? Then, at the end of week one, he's going to put all the checks from this week into this cardboard box, right? And then what he's going to do is he's going to say, right, I'm going to take, now this is where you have to suspend disbelief. He's going to get a special pair of scales, which he's managed to get hold of on eBay or something like that. I'm sorry, I'm really bad at drawing scales. And what's special about these scales, and this is kind of key to the whole analogy, right? These are the most accurate scales that you've ever come across. They're so accurate that they will give you a unique reading that is so accurate that it records down to the atom level, right? And what I mean by that is if I take a piece of paper, put it on the scales, take it off again, and then write a little squiggle on the piece of paper in pen, the scales are going to give me a different reading, right? Because there are new ink molecules on that piece of paper, and so all I'm trying to get across is that these scales are so accurate that they will pick up anything, right? So so what he does is he says, right, get this box, so close the lid after he's put the checks in, and just pop the box on the scales, okay? Then what he does is he takes the reading from the scales, right? So let's say this is like 150, or let's say in kilograms, it might be like 0.1512, That's going to be an extraordinarily long number. Again, it doesn't really matter for the sake of the analogy, but it's so precise that it records every single pen stroke on each of these checks, right? If you're familiar with hashing, I don't want to go too far down that, but that's the equivalent of what we're doing here, right? So we're taking a unique identifier that uniquely sort of signs or represents the contents of this box. So then what he does is he'll takes this reading and then he fills out a label, right? So he fills out a label over here, and basically on the label he writes two things, basically just the box ID, right? So and this would be 1 because it's the first week, right? So it's box number 1, and then he's going to do the weight. So basically he's going to have to write down the weight that he's read off the scales on there, right? And again, it's an extraordinarily long number. Perhaps it would even be too long to fit on a sheet of paper, but just bear with me with the concept, okay? So then what he does is he sticks the label to the outside of the box, right? ID 1 and the weight written something like that, right? So now he has his first complete box of checks, and he has the precise weight written on the outside. Now, you might be thinking, well, any dust particles that are in the room sticking to the box are going to change the weight if you weigh it again. Let's pretend that the room itself is also, for the sake of this analogy, completely surgically clean. There's not even a single atom of dust in the room, all right? So just in case you're sort of wondering about that. So anyway, that's week 1. Now, so he does that on Friday, puts the box in the corner of the room, right? Now, in week 2, right? Week 2 comes along. So in the corner of the room, the guy has the box from week 1, right? With the label on it, like this, ID 1, and the weight, right? So that's in the corner. Week 2, the guy has to basically box up all of the checks that have come in week 2, and let's say there are 960 this week. So what he does, our little guy over here, he takes a new empty box, right? Empty cardboard box. And once again, he pops the checks for this week into the box. Now, in week 2 and from week 2 onwards, he does one extra thing, okay? And that is, he gets another piece of paper and he fills out what we're going to call a cover sheet, right? So the label was what he stuck on the outside of the box to indicate what the weight of this box should be. The cover sheet, right? The cover sheet is basically going to say two things. It's going to say basically actually it only needs to say one thing really. The cover sheet essentially says what is the parent weight, right? What that means is, so it means from the previous week, what was the weight of the last box, right? So what he does, because it's week 2, let's say he just fills out these details as well. So week number 2 as well, just to give some clarity. And what he has to do is say, okay, let's, for week 1, find the box where ID equals 1 and find the weight value there and write it down there, right? The same value. So this is nothing to do with the weight of this box. This is the weight of the previous week's box, right? So once he's written that on there, he pops the cover sheet into the box on top of the checks, right? And it just sits on top of the checks there. Then he closes the box and then he goes back to his magic scales again, right? And what he's going to do, he's going to pop that box on the scales. And just like last week, he basically gets a reading of, let's say, 0.231 down to the nearest atom. So every molecule of ink on that paper is basically incorporated into that reading. Then, just exactly like he did in week 1, he gets a label, right, different from a cover sheet. So the label, right, and he fills out ID equals 2. So it's week 2. This is the label for week 2. And then the weight equals, and then he reads off the scales, right? The exact weight. So he copies the exact number down there. I'm just repeating myself over and over again just to make sure that the concept is clear, right? So, and you can probably skip ahead if you know where this is going, but if you bear with me, then I promise you'll get exactly what I'm talking about. So then once he's done that, he quite simply attaches that label to the outside of the box, right? Weight equals 0.23 something something something, again that huge number. And then what he does is he pops that box on top of box number 1, right? So ID equals 2, that's the label, right? And weight equals something, right? So now we have a stack in the corner with 2 boxes, one from week 1 and one from week 2, right? Right, so then let's skip forward in time a bit to week 5. So let's say he's quite pleased with this new procedure and he's been doing it for 5 weeks now. So now he has a handsome stack down here of 5 boxes, right? And they all have the labels on the outside like this. ID 1, 2, 3, 4, 5, and they all have the weight on the side as well, right, on the labels. So the other part is that his boss tells him, right, at the end of every 5 weeks, we're going to have an audit, right? And so our guy over here, so he's already done. Let's say he's already done his processing for this week, for week 5. He's already got his stuff in the box there, and so now he's literally just saying, right, the regional controller is going to come around and he's basically going to check this method that the guy has used to make sure that that essentially the store of checks that he's created is bulletproof and has not, and that it is 100% sure that the contents of any of these boxes have not been changed since they were packaged up and stacked on top of each other. So let's go through how that audit process would work, and then to clarify it in the next slide I'll talk about how this audit protects against somebody breaking into this office and doctoring or playing around with the contents of any of these boxes. So let's just go through the audit process itself. So what happens during the audit? So first of all, we take each box one by one, starting with the top one. So we take blocks number 5, right? And what we do is we basically open the box, right? And we remove the label temporarily. Then we stick it back on when we tidy up at the end of the audit, right? So, but we remove the label from the outside of the box and we just keep it on the side. We open the box. Then what we do is we weigh the box, right? So basically we're going to take box number 5 without the label on it, right? So let's draw the scales here, like this, right? So the box number 5 sits on the scales, right? And there's no label there, right? So the label is just sitting on the table next to it, right? Now, so that's box number 5. And the first thing we check is is the reading on the scales, right? What is that number the same as the weight written on the label, right? So obviously what that checks is very simple. What that checks is, has anybody put anything else into box number 5 or taken anything out of it, or even written something on one of the checks inside box number 5, because these really accurate scales will pick that up, since box number 5 was weighed and since the label was created, right? So that's the first thing. So check the weight of box number 5 versus the label. So once that's done, then this is where the chain part comes into it. Okay, so what we then do is we say, right, well, open the box and take out the cover sheet, right? So take out the cover sheet. And if you remember in the previous slide, what we write on the cover sheet is basically the parent weight here, right? So that's the previous slide. So we take out the cover sheet and we look at the parent weight, right? And then what we do is we say, right, what is the previous box? It's the box from week 4. Okay, so what we do is we compare the parent weight and we compare it to the weight written on the box below, right? So let's just recap that again. We look in the cover sheet of box 5, which tells us what the weight of the parent box is supposed to be. And when I say parent box, I mean the previous box. We're in week 5. The parent or the previous box is week 4, and we compare the two values, right? Now, what does this protect against? So, if somebody, for example, has changed the cover sheet in box number 5, that would already have failed the first check because that would have altered the weight of the box. So as long as the parent weight on the cover sheet matches the weight on the label of the previous box, then the link between those boxes is preserved, right? So then what we then do after that is we repeat this process, but with box number 4. Okay, so then we take box number 4 and we do the same thing. We'd open the box, we'd remove the label from box number 4, we weigh it. Okay, we check that the weight on the scales is the same as the weight on the label. That again checks that nobody has actually modified the contents of box number 4. And then we look at the cover sheet, right, inside box number 4, and we check the parent weight, right, the parent weight or the previous box weight written on that cover sheet, which would refer to box number 3. Okay, and we compare that value with the label on box number 3. Okay, so it makes sense. So what we're doing here is we're saying these boxes actually have a dependency on each other, and when we come to validate the entire chain, right, of boxes, I'm introducing the word chain there just to get you familiar with it. And when I say chain, so chain is basically because there's a dependency between these boxes or blocks of transactions, in this case checks, right? So I'm just introducing the terminology gradually. Now, if you can see, this process repeats all the way down to the bottom, and the only difference is at the bottom. When we actually validate the box number 1, again we basically this time we don't need to open the box. The ID equals 1. So what we know from that is that there's no previous box, and if you remember on the first slide for week 1, we did not actually insert a cover sheet into box number 1 because there's no parent, there's no previous box. It's week 1, so that's so in the Bitcoin world that's called like a genesis, or the genesis block is basically the first ever block in the chain, right? So when we see ID equals 1, we know, okay, well there's no parent weight here, there's no parent weight to check, therefore don't bother opening the box. But yes, I will still have to weigh it on the scales, right, and check that nobody has actually inserted anything into box number 1. So that's really the sort of start to finish audit process. Now, you might be wondering why we would do that. So let's actually give an example of a scenario where this audit would pick up on let's say some dodgy foul play, right? So here's a simple scenario, right? So let's say just before the audit, right? So that audit happened on Friday of week 5, and right now, so it's Thursday, right? Let's say it's Thursday of week 5, right? So we have the block for week 5 hasn't been inserted yet. That happens on Fridays. So our labels on the outside of the boxes, as usual, have the ID of the box and then the weight values. I'm not going to try and write out some numbers there. Just weight 4, 3, 2, and 1. Right. So ID and weights. So that's our boxes. Now, try and imagine this scenario. Let's say that one of the bank clerks, like one of the people who work at the till, they realize that they have a check sitting on their desk that they forgot to pass to the back room, right? And the date that check came in was sometime in week 2, right? So let's say this poor person who works on the till, right? They basically they know that the policy is, if you don't give the checks that you receive over the counter to the back room for storage within the right week that you get them, then you get fired instantly, okay? Because they take it very seriously, and it messes up the whole policy or whatever. So what happens is this person now realizes, okay, I'm in a bit of trouble now. I'm going to get fired unless I can find a way to break into the check storage room, right, and insert this check into the box from week 2, and hopefully I can cover up my tracks, and then nobody will be any the wiser, right? And if somebody goes to and says, where's that check number, they'll say, oh, it's in, I submitted it, it must be in the box for week 2. Okay, so let's say this person, what they do is they break in at night into the storage cupboard, right? And they basically take box 4 and box 3 off the stack, like just put them on the floor. They open, right? They open box number 2, and then they just pop the missing check inside box number 2, and then they pop box number 3 on top, and then box number 4 on top, and then they run out, close the door, and wipe their fingerprints off the doorknob and all that kind of stuff, right? And they think, great, I've done my job, and I'm safe, right? So let's say this had happened on the day before the first audit. So let's skip forward, and so basically what we're saying is now we have our 4 blocks. Okay, it's week 5 again, week 5, and it's Friday. So first of all, let's draw that one down here. So first of all, you got your blocks, and then let's say so our trusty check storage guy has actually just finished processing his box for this week's checks. He stacked it on, and then our auditor comes along and says, right, it's time to audit this stack to make sure that everything is shipshape, right? So I'm not going to go through the whole thing again. He'll take box 5 and validate it by comparing the weight on the label with the weight on the scales by removing the label. He'll check the cover sheet, look at the previous weight on the cover sheet and make sure that it matches this one. He'll take this one and do the same. He'll look at the cover sheet in this one and make sure that the previous weight equals the weight written on this one, etc., etc. Now, these will all be fine, right? They'll be fine. So what happens when he comes and takes box number 2, right? What happens then? He will put box number 2 on the scales, right? And they'll find, oh, okay, the value on the scales is now different to what is written on the label there, right? So that will instantly flag up that that basically there is something wrong, right? That box number 2 has been tampered with, and alarms will go off, and they'll have to. They won't necessarily know why the weight is different, but they will know that something has gone wrong, something's being tampered with, and then they would launch their whatever internal inquiries or whatever you want to do. So that's how that validation process will pick up the fact that a box has been tampered with. Okay. Okay, so that's one aspect of the tampering that gets picked up. What if our till clerk who was trying to break in and fiddle the system? What if they'd been a bit smarter and they'd known about the label system, right? So they knew that actually, if I need to make sure that the weight, okay, on the outside of this box, for example, ID 2, this is the week they're interested in, right? So they know about this system, or they know a little bit about it, and they've heard that these labels basically get validated, and that each box is taken, put on the scales by an auditor once every 5 weeks, and if the weight doesn't match the label, then alarm bells ring and inquiries are launched, etc., etc. So what if they tried to cover their tracks by saying, okay, I'm going to break into the office again, I'm going to put my missing check, right, into box number 2, but instead of just putting it back where I found it, I'm also going to put box number 2 back on the back on the scales, right? And I'm going to print out a new label, right, which says ID equals 2 and weight is, and then the new weight of box number 2 with the missing check in it, right? And let's say that, so what they do is they take that label and they stick it on top of the previous one, or they remove the previous one and put this one on it, or whatever, right? So now they think, oh, they're feeling very pleased with themselves because now they say, right, fantastic, I've now got, now once the auditor comes and weighs this box, the weight on the box will equal the weight on the label. But unfortunately for them, the system is smarter than that, right? Because if you think about it, so this is box number 1, this is box number 2, 3, 4. So when the audit comes, so let's fast forward to the next day, Friday, when there were 5 blocks. So the auditor comes in, and then because of the cover sheet and parent relationship, box 5 is going to be fine, box 4 is going to be fine. When he opens box 3, okay, takes out the cover sheet, right? So ID 3 and parent weight equals such and such, right? W2. This value here. That was supposed to be the first initial weight of box number 2 when it was first created. So now he checks the parent weight, the previous weight of on the cover sheet of box number 3, and now it no longer matches the new weight on the label of box number 2. So straight away, once again, alarm bells are ringing, right? So there's 2 ways to validate. This is how the whole blockchain dependency between each box ensures that you can't just basically go and change the contents of one previous box. So if we just continue and basically finish the analogy, right? So what our poor till attendant would have to do to cover their tracks fully, right, is this. And I think you can probably see where this is going. Essentially what they'd have to do is they'd have to come in, right, on the Thursday. Remember, this is Thursday week 5. So there are 4 blocks. And what they'd have to do is they'd have to modify all 4 blocks, right? First of all, they'd have to put their missing check into box number 2. They'd have to reweigh box number 2 and put a new label on the box. But as we've seen in the previous slide, they can't stop there. What they need to do then is they need to open box 3, open the box, take the cover sheet, right? And then they have to change the parent weight to the new value, the new weight of box number 2, right? The previous weight, right? So they have to change that value there. Then they have to put that cover sheet back in the box number 3, but then they have a new problem, right? Because now box 3 weighs a tiny little bit more because they've changed the value on the sheet, right? There's a few extra molecules of ink on that sheet. So now they're going to have to re-weigh box number 3. So they have to put box number 3 on the scales, right? And then they have to print off a new label for box number 3. Weight equals, and then the new weight of box number 3. Then they have to put that label on box number 3, right? But then hopefully you can see they have to do exactly the same for box number 4 now, because the cover sheet inside box number 4 points to the old weight of box number 3. So what we've seen then is if you actually want to change And this is the absolute crux of it. So I probably, this has been a bit long-winded, but hopefully, if you can watch it double speed or whatever, and you know, the most important thing is that the concept is clear, right? So if you want to modify a block or a box in this case, you then have to reprocess every single box in the chain from that point onwards. Otherwise, the validation that happens is going to fail, right? And that really is it in a nutshell. Now, that kind of explains the main concepts behind blockchain, as in you're taking a block of transactions of some sort, grouping them together, creating a unique representation for that block of transactions, and then you're chaining them to each other in a way that basically cannot be modified historically without processing every single block since the block that you want to modify. Now, blockchain, there's one other key aspect of blockchain that this analogy has not kind of covered, which is the distribution aspect of it. So if you look up probably in the dictionary definition of blockchain, you probably see something like it's a distributed, often public, but not necessarily, but a distributed ledger of sort of interdependent blocks of transactions. But the distribution side is key because and that's where the power of blockchain really comes in. We'll go into that in subsequent videos. But just to sort of finish the analogy, I want to say, for example, that the bank has decided that this guy, our guy who's storing the checks, he's very good at coming up with ideas and innovating this process, but he himself can't be trusted because he himself was found to have gone back in week 3, right? Let's say this is in week 8 or 7, right? So 1, 2, 3, 4, or 6 or whatever, right? So let's say our very own guy who came up with this method and stores the checks, let's say he missed putting a check in box number 3, right? So let's say he missed doing that 1 week, and he also gets fired if he fails to make sure that every check is stored in the correct slot. So let's say he had gone in and actually covered his tracks. Obviously, he designed the system, so he knows exactly what he has to do. He has to put the missing check in week number 3, reweigh the box, redo the cover sheet for block 4, and then reweigh it, and then redo the label all the way up to 6, right? So basically, what that means is that blocks 3, 4, 5, and 6 are actually not the same as the blocks that he first created, right? So he obviously would feel, okay, well, my system is bulletproof and nobody's ever going to know that I put an extra check in block number 3. So let's say the bank finds out because I don't know, because he wrote it in his diary or something or whatever, and they find that this guy can no longer be trusted. So what the bank decide to do is say, right, instead of just taking the paper checks that get paid over the counter, what we're going to do is we're going to store photocopies of the checks. Sorry if the analogy is getting more and more far-fetched by the second, but we're going to take the checks that we get over the counter and we're going to photocopy them 4 times, right? So each check that comes in, right, we're going to photocopy 4 times, and we're going to give a photocopy to four different people. So we're going to employ 3 more colleagues for this guy, right? So now instead of storing the original check, we're going to store the photocopies in paper form, which might seem a bit silly, but in paper form, and so that the originals will be thrown away and the photocopies will be stored, and each of these 4 people will be responsible for maintaining their own completely separate stack of boxes, and they'll all do it in separate rooms, but they're all processing exactly the same checks coming in, because some person gives them each a copy of every single check that comes in, right? So let's say, so all these 4 people are maintaining their own stack of boxes, right? I hope I get better at drawing as the series goes on. This is the first in the series, so please bear with me, but this is going to be worthwhile. So let's say each stack has 4 boxes, and the reason they do this is because when the audit comes along, right, what happens is that if our guy, who's not to be 100% trusted, if he had changed any of these blocks, right, to cover his tracks, all these other guys, their stack would be identical, right? So the contents, the weights on these blocks would be all identical, right? But this guy's would not. And straight away, the auditor knows, okay, something's wrong here. You must have, if all these 3 guys have consistent contents of the boxes, consistent weights, consistent blockchains, and you have a valid blockchain in terms of the chain and the dependencies and the labels, but the values are different, this guy's in hot water again, right? So I know that's been a bit long, but I hope it's kind of illustrated what blockchain is. So in the next video, what I'm going to do is kind of continue, or let's say bring the analogy more into kind of digital context. So we're going to talk about hashing, which is effectively digitally putting those boxes on the scales. And we're going to talk about how, give you an example of a real blockchain in action, right? So thanks for bearing with me. Thanks for watching. Please stay tuned for the next video. If you've got any questions, any feedback about any of this, constructive or otherwise, please leave it. And thank you for watching. Right.